All right, welcome back, Drive-Thru Confessionals. This is the 5-6 version, special Johnny Chan edition. Hungry? Get some General Tso's, Johnny Chan too. All right, we're going over our warm-up. We're taking questions from 5-5, and we're doing a real quick review of the 5-6 notes. I call this the deja vu section because it's almost like the book understands that they went through this way too fast, so they give you a chance to go back and slow down. So today, after we go over our review, we will focus solely on proving things to be parallelograms. So it's literally going to feel like deja vu, but you need it. We've gone too fast this week, so this is great. When is your test? Thursday. So we have some time. But I'm telling you, if you feel like you're a little behind right now, this is your chance to get the help you need in the next 3 or 4 days. Because you're not going to be added a whole lot of information. The hardest part of catching up is learning what you missed, but also learning the things that get applied in the now. So what I'm telling you is you got a really good chance to get caught up right now because we're not adding a whole lot of new information for the rest of this chapter. Okay, I'll draw some diagrams for some of these. Rhombi have perpendicular diagonals. Actually, a really good way to draw a rhombus is start with two lines that are the perpendicular bisectors of each other, and then just, it must be a rhombus from that point. Okay, so that's always. How'd we do on that one? Okay. Trapezoids only have two different angle measures inside. This type of trapezoid has how many different angles inside of it? 4. This type of trapezoid, which is what? What am I going to draw here? An isosceles trapezoid has only 2. That makes this a sometimes answer. Parallelograms have diagonals that bisect the angles. Well, a typical parallelogram, I won't even draw that typical of one, kind of a long one. Is this angle look equal to that angle? No way, no way. Okay? What if that parallelogram looked like a rhombus? So what's our answer? Sometimes. Rhombi are parallelograms. What's the definition of parallelogram? Somebody give me a good one. Yeah, Big James. Excellent. A parallelogram is a quad with 2 pairs of parallel sides. Would you say that this figure is a quadrilateral? Does it have 2 pairs of parallel sides? That's how you know a rhombus is always a parallelogram. Or maybe you remember our little chart and you know that the rhombus is the offspring of a parallelogram. Parallelogram. Kites have opposite angles congruent, not both of them. So that is actually never. But I'm going to try to stay away from questions like that because your book would have that answer as sometimes. Your book and I disagree on the definition of a kite, but it's okay. Parallelograms have consecutive angles congruent. Here's a parallelogram. Is this angle congruent to this one? Is that a parallelogram? Are these angles congruent? So the answer is sometimes. How'd you do on those? Okay. Okay is the answer to that question. I did okay. All right. Another chance to learn. Now let's take some questions on the homework. You mind if I use your book? I'm sure you didn't. Yes, so number 9. Prove property 4 of rhombuses. So you would never have to memorize these properties by number. So that wouldn't be a fair way to ask this question on the test. But you turn back And you say, prove the diagonals of a rhombus bisect the angles. Prove that the diagonals of a rhombus bisect the angles. Alright, I'm going to use my super special theorem on this one. The one that I think I forgot about until somebody in this bell or first bell reminded me of it. Oh, let's go with R H O M B. So we remind ourselves that is indeed a rhombus. R H O M is a rhombus. That's what's given. Okay? Here's the super secret special theorem. Triangle HBO is congruent to triangle HBR is congruent to triangle MBO is congruent to triangle MBR. Now the theorem takes a while to write, but it saves us so many steps. If rhombus, then diagonals divide quad into what? 4 congruent triangles. Did you know that one? So now I can say that angle HOB is congruent to angle MOB. I can say that angle, HRB is congruent to angle MRB. I can say that angle RHB is congruent to angle OHB. And I can say that angle RMB is congruent to angle OMB. That may be the single biggest CPCTC step of all time. And from there, I can just write, I guess, HM and RO are angle bisectors by definition of bisect. The longest 4-step proof in history. Okay? Thanks for asking that, Soph. What else? How'd you do on some of the algebra questions? 19. Yeah. All right. KMOP. What is that? What does that spell? I mean, are they even in order? Is that a random order of letters? HIJK. Where did L go? And where's N? I don't get it. It makes me mad. All right, angle M is x plus 3y. Yeah, if this was a C and they were trying to do comp, I'd be down with it because we do have comp. No, we have supplementary angles here. All right, angle O is x minus 4. And angle P is 4y minus 8. And what does it want us to find? Angle K. This is a classic test question. It's testing whether or not you know the properties of parallelograms, and it's testing whether or not you can do algebra. It's a perfect question for this class. So, what do you notice about what our givens are? We have some x's and some y's. I know that M is congruent to P, right? So I can say that x plus 3y is equal to 4y minus 8. Can I solve this blue equation and get an answer that's a number? I cannot. There are infinitely many answers that work. Okay? And I also know that, which one would I do? It doesn't really matter. I got to say that either these are supplementaries or that these are supplementaries. I'm trying to figure out which one would be easiest. I think I'll go with O and M because then I can solve for x and I don't have to do a system of equations. Does that make sense to everybody? I could have said that this plus that equals 180, but then I'd have two equations with two variables, which we can handle. But the easier one to do, oh no, they're both going to be systems. Sorry. So I'll go like this. X plus 3y plus x minus 4 equals 180. All right. Here's a little trick. I'll just show you a little algebra trick, even if you did this right for homework. See how this says x plus 3y equals 4y minus 8? If I do a little math, I can do x plus 3y is equal to 180 minus x plus 4. Can you see that? And now, well, that's not going to really do much for me. I forgot that this had an x. I could set these equal now if I wanted. That's not going to help us a lot. So negative x is equal to 4y minus 192. So x is 192 minus 4y. Okay, we've just solved for x in terms of y. There were so many different ways you could do that, okay, honestly. But now that we have this piece of information, we'll go back and plug it into the equation we didn't use. So into that one. And I say 100 and, well, let's clean that equation up first. 2x plus 3y is 184. Now I'll plug it in. 2 times 192 minus 4y plus 3y is 184. Oh, 384 minus 8y plus 3y is 184. Negative 5y is equal to 184 minus 384, negative 200. All right, so finally, y is 40. Plug it in here. X is 192 minus 160, so 32. Now, we got to go up. X is 40, or y is 40, x is 32. They're looking for angle K. Angle K is the same as what? Angle O. So angle K is x minus 4. So angle K is 28 degrees. Tough question. Okay? I'm sure you could do it quicker. Do you use substitution? Okay. Instead of, well, that's what we did, but they did a quicker way of substitution. Yeah. Next. We're good? Okay, that was a good homework review. Very typical of what your test will be. About half proof, about half short answer, which are algebra-based questions. Okay? All right, let's get down to it. We got 5 ways to prove things parallelograms based on what we've done for the last, 4 days. We're just going to write the shorthand version of these theorems. Okay? Would anyone like to lead it off? Excellent. So here's how I'd write this in a proof. If opposite sides are parallel of a quadrilateral, then that shape is a parallelogram. Okay? We're going to have 5 of these. Who can give me the next one? Or a next one? There's no order. Excellent. You could really have said either. If the opposite angles of a quadrilateral are congruent to each other, then that quadrilateral must be a parallelogram. Parallelogram. Audrey, did you find it? Okay. Show me on Monday, okay? Jamin, you got the next one? Stretch it out. Get ready. Get loose. All right, this is the one that people forget about, I think. If what have I just shown there? He said it, but I don't know if everyone heard. That's fine. Van? If the diagonals of a quadrilateral bisect each other, then that thing is a p-gram. Don't laugh at that. Hey, happy birthday, I got you a p-gram. You know, like a singing telegram or a jokergram? A p-gram. No? No? Thank you. Next. We're missing one of the more obvious ones. Yeah, Nick. Excellent, Nick. Thank you. If a quadrilateral has opposite sides that are congruent to each other, then that thing must be a p-gram. What do you guys think about teddygrams? I agree. Except for the chocolate ones. Not down with chocolate teddygrams. What do you think about Dunkaroos? Do you know about Dunkaroos? They're like a teddygram. You know that disgusting snack that everyone kind of loves that's like a package that has cheese and pretzels and you dip the pretzels in the cheese? Audrey just almost threw up. Okay? But imagine that, only with teddygrams on one side and icing in the other side. That's what a Dunkaroo is. I don't know if they still existed, but they existed when I was a kid, and they were awesome. But you just go bombs away, finger into the icing, eat all the icing, and then maybe eat your teddygrams. You got something to say? That's fine, Audrey. We'll put it on there. Oh, that sounds good. You got the last one? What is it? So I don't know why, but the book doesn't list that one. And I would guess it would just because you would use those to show that the lines are parallel. And it would be easier to show the lines are parallel than to say that all the angles were supplementary. But that would definitely work, and I would take it on the test. This one, I don't think I've told you about yet. This is the only new piece of information for the day. So, if one pair of opposite sides are both congruent and parallel, then that quadrilateral class, it's a p-gram. And those are your notes. So don't you feel like deja vu? So you should feel great about this homework. It's relatively short, okay? It's a great chance to get caught up and then either get ahead or go back and reteach yourself something that you might have missed along the way. That's it for today. Boom. Shout out to all my field trippers, my Model UNers, and my Disney Worlders. We miss you guys. Yeah, let's clap it out. Thank you.